Alright, so I'm going to show you how to do a couple of the last problems from that one worksheet. I just want to make it clear on the different ways that you can draw force diagrams. I want to kind of leave it open to you on how you would prefer to draw it. I'll tell you my recommendation, but there are a few things that you're going to have to keep in mind as you do it, and I'll address this as I go along. One of them that I'd like to address is the one with the tree, and the guy is kind of taking a break as he climbs up this tree. There's a rope there, and he's hanging on that tree. So I'll show you the way that I'll do it, that I'd like to do it if I were doing the quiz myself. The first thing we do is we identify the system. In this case, it's going to be the camper, and we condense him into a single point. Gravity always acts downward. We know that we have a tension force going up along that rope. The tension force has to act along the rope. It can't act up, down, over. It's always just along that rope. And then we have the normal force, which is perpendicular to the surface here. So that's going to look like that. The lengths of these I'm not sure of exactly just yet. This is kind of like my rough sketch. I know there's a normal force. I know there's gravitational force. I know there's a tension force. There might even be a frictional force. We can include that as well. That would also be along the tension because it would be keeping him from sliding down. But for now, let's just leave the friction out. So I would prefer to turn the x-axis, or the entire coordinate system, to be like this. So you have x and y. So that makes the normal force in the y direction and the tension in the x direction. And the only one that you have to deal with now is this force of gravity. So now we split it up into components. You have the force of gravity in the y direction and the force of gravity in the x direction. And if we assume this guy's at rest, then we would say this one should be equal to that, and this one should be equal to that. In all honesty, if you put this on the quiz, I would be happy with that. The reason for that is it shows me that you know that there's a normal force, a tension force, and a gravity force. You know which way they are actually acting, and then you know that we would need to analyze which ones are equal to each other. You would say that this is at rest, so that's perfect for me. And then you showed me that the normal force in the y direction has to be equal and opposite to the gravity force in the y direction, and the tension force in the x direction has to be equal and opposite to the gravity force in the x direction. That understanding shows me that you know what's going on in this force diagram, what's going on with this guy. You know he's at rest, you know that these are balanced. This is what I would prefer. However, number one, if you want to go ahead and clean this up, some people don't like the diagonal and then having the components, so then you can just go ahead and solidify this force of gravity in the x direction, and we just get rid of that diagonal one. So then we just have this, the force of gravity. Oops, this is in the x, this is in the y. And then you would have the force of tension, and then you can redraw your hash marks. And so this would be acceptable. I know that some people prefer to leave gravity just going straight down and would just like to break these up into components. Oh, sorry, I can't say these up into components. So if you would like to do that, by the way, I draw this as just the mountainside. Then you would draw force of gravity going down, normal force perpendicular, tension force along the side there, and then you would just break these up into components. This can be misleading only because you might think that these two are equal to each other and these two are equal to each other just in the way that you drew them. That's actually not necessarily the case. We know that this one plus this one has to equal this one, and we know that this one has to be equal to this one, which is the case if we are at rest. But this one might not necessarily equal this one, and if you put hash marks on these on the quiz or the test, that's going to be wrong because you don't necessarily know that. So don't get confused with that. However, if you do leave it like this and then you want to break this up into components, Fty and Ftx, and Fny and Fnx. Notice you have a lot more forces going on than you did in the previous one. And now you would have to go ahead, if you want to clean that up, and you would say the tension in the y direction plus the normal force in the y direction would be equal and opposite to the gravity force, and then the normal force in the x direction is equal and opposite to the tension force in the x direction. And so these would have hash marks, and if you want to go ahead and do that over the sum of these, you can do that too. And that might be, more satisfying for you. That's up to you. But all three of these here would be sufficient. And the idea here is that it shows me that you know which forces are acting on it and how they are balanced, if they're balanced at all, and that you can split up vectors into components. That's what I'm looking for. That's what I'm grading on, if you understand why this is. So that's the key there. I'll show you one more quickly, and then we'll be done. So let's look at the magazine rack one, because I think that's a challenging one. We actually have two different surfaces here, which makes it interesting. So here's our magazine, and I'll actually go ahead and draw the force diagram right on the picture. Sometimes that helps me see how the angle should go. So I'll do that for this case. So gravity always acts straight down, but notice now that the book is being supported not only by this ledge, but by this. It's not falling through this way, it's not sliding down off of the rack. It's being supported by two surfaces, so those two surfaces can both provide their own normal force. So we have a normal force going this way, and we'll call that normal force 1. And we have a normal force going perpendicular. So this one's perpendicular to this one's perpendicular to this one. So normal force 2. If we say that this thing is at rest, we know that the sum of these have to equal 0. The forces are balanced. So from here you can go ahead and break these up into components if that pleases you, or you can turn your axis to be along the magazine rack and just break up the force of gravity into components. Why don't you try that as I go ahead and do it now. So I'll do it my way first because I prefer this way. So we would break the force of gravity into components. We have this one and this one. Force of gravity in the y direction, force of gravity in the x direction. This would be equal to this would be equal to that, and you're done. That is all I would require on the quiz or something. However, if you want to go ahead and do it like this, you would have normal force 2, normal force 1, force of gravity, and then you would break it up like this. This is normal force y, normal force x, normal force x, normal force y, and this is 1, 1, 2, 2. Notice you got a lot more subscripts, a lot more forces. You don't know that these are necessarily equal to each other, and I think that's where a lot of people are going to make their mistake if they draw this like this. You cannot put hash marks on these. You do know that these are equal to each other, and you know that this plus this is equal to this because they should be at rest. So if you redraw it, you would write Fny1, Fny2 is equal and opposite to Fg, and those are equal to each other. And then you have Fn x1 and Fnx2, and those two are equal to each other. And so this would be acceptable as well as this. So hopefully that helps you with forces at an angle. Remember, what I'm looking for is your understanding of how these forces work, being that normal forces act always perpendicular to surfaces, gravity always acts in the downward direction, showing that you know how to break vectors up into components into x and y, however your x and y axis may be altered if they're just regular or if they're angled at some point. And then showing how they balance out if they do it all. If this thing was accelerating, you would want to show one being longer than the other, or if this thing was balanced, you would want to show them all with hash marks so that I can see which ones you think are equal. Alright, so remember not to just worry about the formalities of drawing this, but just to show that you understand how these things work. Alright, so good luck tomorrow.